the astronomers got a signal that spelled, first you got a beep, 1, and then 2, and then 3, and all the way up to 101. And they concluded that this cannot be a result of any natural process. So they concluded intelligent design in that movie. And I might come a little back to this example. Here is another example. This is Josh Harrison. I think is there sound?
Sounds really like the
Hvis det lige pludselig går igen, så er det lidt high. Prøv at skrue op på din computer.
Hvor er det henne?
Så er der ikke noget. Hvad skal du på?
Det er okay. I'm playing.
My hearing is not so well, so I'm not going to get anything out of this before.
No. Anyway, it's my sweet Lord with Josh Harrison. So I think we all know this song. Or do we?
Not the young generation.
The young generations. Anyway, this is a famous song by Josh Harrison, My Sweet Lord. Probably actually inspired him to sing this song. But what I'm using it here was actually turned out that there was another music group that sued Josh Harrison for having copied their song. And probably didn't. Or he didn't do it consciously, but actually he lost the case and he had to pay a huge fine. So then the question is, how did they conclude that this is a copied song, it's not an original song? That's also a discussion on intelligent design actually. Is it just chance that they're so identical, these songs, or is it beyond chance and it must be a conscious or deliberate act on the part of, in this case, Josh Harrison. You understand? No. So that's also kind of a discussion of intelligent design or use principles of design detection. Or if you have here's another example. This is a map of Sweden, Finland, basically. So. Here, it's not because we want to discuss geography as such, but I want to ask the question. There are those who are publishing maps, how do they protect their copyrights? Also, maps is an example. Also, before we had electronic calculators, then everyone had tables of logarithms and sinus and cosinus and like that. Anyone? Yeah. That all? Yeah. So how would they, the publishers of in the cosinus or sinus table, how would they protect their copyrights? Because how do you do? You cannot make a copyright of the right answer or a map. How it's not you. You just make a copy of something that's already there. You cannot copyright the land or the country. So how would the publishers of maps protect their copyrights, or publishers of mathematical tables protect their copyrights? Any idea?
They cannot do that.
No, but actually they had a way.
Who published?
Yeah, what?
Whoever published it first and say I have published in this particular date.
Yeah, but again, it's like, I have copyright on 2 + 2 is 4. After I was the first, then nobody else can write that in the books. That doesn't work like that. You cannot.
Maybe they add something of less significance to make it distinct.
Yeah, actually, that's the answer. They actually, add a few mistakes here and there. For example, on the tables, logarithmic tables, on the 7th and 8th decimal, there might be a small mistake, which doesn't affect anyone. Nobody needs 8 decimals anyway. but you cannot copy. You have no copyright on the right answer. But if someone has made also published a table and have all the right ones, that we cannot. But if they also have precisely the same mistakes, then we can say you have copied. And similarly with maps, they will also add a town that is not there, for example, or a mountain or something. There'll be some subtle things, small things, but it will be some. And that's how they protect the copyrights. So if there is a court case, then they can actually use design detection and say, no, here we have plagiarism. So that's another instance where this discussion is this chance or deliberate fraud? And so with these examples, I want to ask the question: how do we infer intelligent design? And here one use what is called Dembski's explanatory filter. And and now this is going to look a little technical for you. I don't know if you get what this says, but this is it's a mathematical filter or design filter where you of course begin with the start, and then you have to ask 3 questions, and if you can say yes to each of these questions, then you have a feature that is intelligently designed. I'll give you an example. Have 3 strings of letters. Can we conclude that these were designed or not? First one is this, T-O. Can we conclude that this was intelligently designed? It's the first question one has to ask, was this contingent? And what does that mean? Contingent means it's something that must happen. Actually, we imagine now we have a keyboard and we have a monkey. That's actually what we're testing. And we have a suspicion, actually it's not an ordinary monkey, it's an intelligent monkey. So we let the monkey type something. And here is the first thing that the monkey types. So the first question, contingent, did it have to type T-O? And the answer is no, it's not something that had to happen. Contingent things that happen is something like if I let this go, this is contingent. It will fall all the time. It's a law. So, if it's contingent, it means it's the opposite. It's something that doesn't have to happen. That's what the word contingent means. So it didn't have to, the monkey didn't have to write T-O. So it's contingent, yes. The next question is it complex? And here we have to answer, no, it is not complex. T-O is very simple, it's just 2 letters, isn't it? So that's simple. So we cannot conclude, it could just be chance, that the monkey just boom, boom, and T-O, that was. So then we get the next string of letters here. A number of letters like that. And again, we asked, was this contingent? No, it could have been any other string of letters. Then the next question is it complex? And the answer actually, it's very complex. It's probably so complex that probably never before in the history of mankind, maybe not even in the history of the universe, has this string of letters come out precisely as there. So it's very, very complex, string of letters. Is that clear? Complex? But then we have to ask, is it specified? And I'll get back to what that means, specified. But here, because even though it's very complex, we will conclude probably it was chance. The monkey was just, punching here and there, and it looks like, it could easily be chance. So the point here is actually that just because something is very complex doesn't mean that it is not chance. Complex things happen all the time by chance. So sometimes someone will make an argument for design by saying, oh, this was very complex. But actually, that's not strong enough, that argument. You can have all kinds of complex things happening all the time by chance. So, so we cannot exclude chance here. Here we have, let's see here. Just 1 second. So I'll try here. Yeah, there we go. Here we have another string of letters, which I mean, it's contingent. It's not a string of letters that had to. It could be any other string of letters. It's complex. It's definitely a complex string of letters. It's as complex as the string above. But besides being both contingent and complex, it's also specified. It means it carries what do you say, actually an independently given meaning. It's actually to be or not to be, that is the question. It's a sentence from Hamlet, Shakespeare's Hamlet. So specified means it's an independent pattern exists that corresponds to this trait or event or string of letters. Do my words make sense? Hamlet exists independently of this string of letters. It existed before the string of letters were written. And still, we have the same sentence as in Hamlet. So, if you have some independently existing pattern that matches the pattern you're studying, then you can say, this is not chance, this must be design. And even if Shakespeare had not written that, we still would have said, this is not chance, because it has meaning. It has an independently existing meaning, independent of this string of letters. And this is called specified complexity. And according to this, it's a complex feature that matches an independently existing pattern. Everyone understand?
Not quite. A complex feature that
matches an independently existing pattern. I mean, a complex feature, you understand? And in investigation we find there is a pattern existing independently that matches this complex feature. For example, when the astronomers in the movie Contact concluded that these sequence of the prime numbers up to 101, this cannot be chance, this is designed. Why? How did they conclude that? Because the prime numbers exist independently. It's a mathematical significant string or sequence of numbers. They exist independently of this signal that they got from, in the film. You understand? Prime numbers exist independently, and here they have a signal that it's prime numbers. This is, this is beyond reasonable to say that this can be chance. We also sometimes give the example of, the Big Bang building company. You know about this example? Big Bang, have you?
No, I wasn't coming to that.
Okay. That's, it's a joke we do also often make that it's a Big Bang building company. And the way this Big Bang building company is constructing buildings, and actually they're very cheap, so people they say, this sounds really, how can you build something like that cheap? So someone they hires this Big Bang building company and says, this is interesting, but I would just like to know, how do you, what is your constructing method? And then the constructing said, it's very, very simple. We just get a big pile of bricks, big pile of bricks, and the windows, and the pipes, and everything, and the fittings, and like that. And then we just place dynamite under the whole thing, and then we blow up the whole thing. And then, when the whole thing has, exploded and the dust has settled, then the building is there, ready, and you move in. This is how the universe was constructed with Big Bang. This is how we make buildings here. So, we know that that's not possible. Of course, you say it could happen by chance. You cannot exclude chance completely. but the probability for something like this to happen is so vanishingly small that it's not reasonable to assume it could happen. It's not likely that anything like that has ever happened anywhere in the whole universe for the last 14.5 billion years since Big Bang happened according to the modern cosmologists. And why not? Because it matches an independent given pattern. A livable house you can move in and live in is it's an independent existing pattern of the scattered bricks at or just of the bricks. So you understand a little what say specified complexity. So that argument has been given by this William Dembski. He's a mathematician and philosopher, and he has formalized, he's analyzed, how do we conclude design. He says that specified complexity is what allows us to conclude design, intelligent design.
I was just wondering about the sentence, to be or not to be, that is the question. If the specified pattern of that was language?
Yeah, it's language, it's meaning. It has meaning. I mean, in this case, it existed independently before in Shakespeare's work, Hamlet. So, but even if that sentence, Shakespeare had not written that sentence, but you created another meaningful sentence that maybe was the first time you spoke that, but anyone spoke that. Still, you can say because meaning is independently existing of the string of letters, you still conclude this is not chance. So, okay, so that's a little technical discussion. How do we conclude design? Now I'm going to give you some example where it's reasonable to conclude. Here we actually are having design. I'm going to look a little at the universe and look at what is called the anthropological principle, which means that it's the fact that the universe appears to be fine-tuned for life or human life. In other words, there are so many physical constants and factors in the universe that seem to be very, very precise, and if they were not precisely, didn't have these precise values which they have, actually life would not be possible on a planet like this Earth. That's actually the anthropological principle. It's a number of physical constants have precise values that make life possible. If gravity, mass, density, strong and weak forces inside the atom, etc., were only slightly greater or smaller, life wouldn't be possible. And this is something that as cosmologists have discovered over the last decades, actually. Here there's one, Fred Hoyle, a British astronomer who became very famous, and in the 1980s he was actually originally an atheist, and he was a very famous astronomer. A couple of generations ago, or between 1 or 2 generations ago, there was a big discussion among the cosmologists about Big Bang or steady state. And that was before they concluded that there had been a Big Bang. So there were 2 theories about the origin of the universe. One was called steady state, which was a theory that the universe had always existed. And the other theory was Big Bang. The universe had a beginning and has expanded from that point from where it began. And so there was a lot of discussion forth and back. And Fred Hoyle, he was one of the main proponents of the steady state theory. And actually most astronomers like the steady state because Big Bang smells of God. Actually, that was a problem. If it had a beginning, sound like a creation or something like that. So actually most astronomers, they favored steady state and had different theories, and Fred Hoyle had a theory how possibly it could be that steady state was actually there was a universe that always had been. But he as years went on, he had to change his mind, and he actually in 1982 he came out very openly and said, actually, there must be a God. And of course, as a result, he was completely sidetracked. And he became like a renegade. But he writes here, I do not believe that any scientist who examines the evidence would fail to draw the inference that the laws of physics have been deliberately designed with regard to the consequences they produce inside the stars. And I'm not going to get into detail, but it's something about the formation of elements and like that. You can read it in my book. There's a whole chapter on cosmology and like that. There's some discussion there. Here there's another physicist who writes, imagine playing God with the cosmos. Before you is a designer machine that lets you tinker with the basics of physics. Swiddle this knob and you make all electrons a bit lighter. Swiddle that one and you make gravity a bit stronger. You need to set 30-something knobs to fully describe the world about us. The crucial point is some of these metaphorical knobs must be tuned very precisely or the universe would be sterile. Oh, it must be. No, one slide missing. He goes on to give an example about neutrons. If you know in the nucleus of an atom, there are protons and there are neutrons inside the nucleus. And how is it? And then there's electrons spinning around the nucleus. But inside the nucleus, you have protons, which are charged, and then you have neutrons, which have no electrical charge. And let me just see if I can get it right, but is it that neutrons are slightly lighter than protons? Or is it the other way around? I'm not sure. But he writes this as an example, that if it had been the other way around, then none of the processes inside atoms, which are crucial for matter to function at all, they wouldn't have been possible. Wouldn't have been possible at all. Some of this slide fell out. It's kind of neat, and his conclusion is that it's actually. He says it's so perfect. There's some of these physical constants, and if they are just 1% or even 1/10% slightly larger or smaller, the universe would not have been possible as we know it now. And there's nothing about matter or the laws of physics as such that specifies that it must have these precise values, that gravity must have precisely the strength that gravity has, and electromagnetism is precisely of this strength, and the relation between electromagnetism and gravity and so on. It could have been any other, had any other than bigger or smaller, but just happened to be so precisely right that ultimately life is possible here. So that's actually also an argument for design and specified complexity. Life is a very specified thing, and here you have laws of physics which are just fitting to allow life like we see it here. Here is another thing, and this is something I was planning to discuss for the rest. Can we just go on like that last time? Or?
There are scheduled classes at 7:30.
It's a class, like a Gita class?
Yeah.
Okay, yeah. So probably I'll spill over, continue next time on this, because this is a little complex, very fascinating. This is something really fascinating. Here, that's probably where when we start looking at biology, now we can really see that this is really design we're dealing with. But in order to understand this, we have to have a little biochemistry and have a little look at particularly DNA. So I wanted to discuss the DNA. Of course, we all heard the DNA, and everyone knows what the DNA looks like.
He just showed us.
You told us.
Yeah, I showed you here, but
It's
yeah.
written.
Huh?
You told us it's a complex structure with written data on every string.
Yeah,
So last
yeah.
time.
I mentioned that last time. So I wanted to get a little more into with this. But here we have a quote from Bill Gates. We all know Bill Gates, Microsoft, computer guru, software guru. And he wrote here that the human DNA is like a computer program, but far, far more advanced than any software we've ever created. And in order to understand, it's a very good analogy, because actually it's not really an analogy. It's the same technology found in the DNA, which is found inside computers, but it's just more advanced what is in the cell. And if we talk about it, what is a computer? I think I have. Let me see. Before I would actually like to show a film clip about DNA just to get an idea what we're talking about. So again, this is why is the sound so horrible?
You want to spice?
Yeah. Huh? Neutron is heavier than proton. Yeah, good.
I had this kind of test in military also with this kind of sound test.
Perform better on this. I admit that. This is not.
Det er muligt at gøre det lidt...
Here you go. Okay. Yeah. Can you hear from here?
Yeah.
Det var meget godt.